What's going on, everybody? Welcome back to another video. In this example video, we're going to actually be solving general solutions for systems of ODEs that will contain defective eigenvalues. A quick note / disclaimer: because we are going to be working with defective eigenvalues, I'm going to skip quite a few steps in terms of finding the eigenvector and eigenvalue, mostly because this is ODEs. And so if you want to learn how to find those, I will link a video that I did in linear algebra on how to find them and the process behind it, because it's actually it is long. So let's actually get to it. We're going to do 3 examples. Hopefully I can do them within a short amount of time. So let's get started. So the first one, we are given that x1 prime is equal to x1 minus x2, and then x2 prime is equal to 4x1 plus 5x2. And so, as usual, as I always mention when you're working to solving these, always put this in matrix form. And so the matrix form will be x1 x2 is equal to 1 -1 4 5. These are prime times x1 x2. And so now all we have to do is take this matrix and subtract it by lambda times the identity matrix, and then take the determinant of all that, set it equal to 0, and find our eigenvector. So once we do all that, we are going to get the eigenvector to be in 3 with a multiplicity of 2. What that means is we are going to have 2 eigenvectors corresponding with lambda is equal to 3. One of them actually becomes defective, and so we'll have our matrix Q contain the eigenvectors for lambda is equal to 3, and that will just be -2 4 and 1 0. If I remember correctly, I did do example videos that looked at these particular matrices, so I really hope I did. So I'll link to the video on how to actually find them. So that is pretty much it. So this is going to be our V1, and this is going to be our V2. And so our solution will end up being x1, x2 is equal to C1 times e to the 3t multiplied by -2 4 plus C2 e to the 3t, and then multiplied by, actually let me do this. So it's going to be multiplied by -2, not -2 4, 1 0 plus t times -2 4. And so what we can do here is we can combine this portion here and then rewrite this as 1 minus 2t and then 4. And so that just becomes our answer. And so another way you can write it, if you want to write them separately, is x1, it'll be e to 3t multiplied by -2c1 plus c2 minus 2c2t. Or if you want to rewrite this, factor out the c2, 1 minus 2t. And then x2 will be equal to e to 3t times 4c1 plus 4tc2, and then we can factor out the 4 and then have this be 4e to the 3t. So yeah, that will be it for the first example, and let's move on to the second one. So the second one is a 3x3 matrix, and so as usual, remember, put this in matrix form, x2 prime, x3 prime, and this is equal to -5. We don't see an x2 here, so this will be 0, 3, this would be 2, 1, -1, and this would be -12, 0, 7. And it's going to be all multiplied by x, where this is a column vector that has x1, x2, x3. Cool. And so now when we do all the math, we will get a eigenvalue of lambda equaling to 1, and it will have a multiplicity equaling to 3. And then additionally, it will give us 2 Jordan blocks. And so when you do all that stuff, you will have, I think the blocks, yeah, I don't think the blocks are that important. After that, you'll have a matrix Q, which again, I discussed in my linear algebra on what it is, of 0, 1, 0, -6 to -12, and then 1, 0, 0. And so because, oh no, yes, the blocks do matter. So what the blocks mean is, this pretty much tells us how many, how many defective eigenvectors are, or how many ordinary vectors are. So because there's 2 blocks, that means there's going to be 2 ordinary vectors, and so it is going to be v1 and then w1, w2. And so now to write the solution, we will be getting x1, x2, x3 all equaling to c1 e to the t, and it's going to be the first vector. We're going to go from left to right, so it's going to go this way. So it's going to be 0, 1, 0 plus c2 e to the t, and now we have a new ordinary vector, so we will keep, or we'll just have one vector here, which would be w1, -12, plus c3 e to the t, then multiplied by w2. And remember, it is going to be going downwards, so it'll be w2 and w1. So it'll be 1, 0, 0 plus t times w1. So this would be -6t plus 2t minus 12t. And so that will be our solution. Or another way of writing this is having x1 equaling c1 e to t that's 0, c2, so negative, well, factor out the et multiplied by -6c2 plus c3 times 1 minus 6t. x2 is going to be equaling e to the t multiplied by c1 plus 2c2 plus c3 multiplied by 2t c3. And then x3 will be et. This is 0. So this will be -12c2 plus or minus 12t c2. Then again, you can factor out the 12 or the -12 and then just have it c2 plus t c3. That is supposed to be a 3. So yeah, that's how you find, or that's the solution for this one. And then our last example is what looks like 2 equations, so a 2 by 2. But if you look carefully, hopefully you see it, this is x3, then this is x2 prime. So this is a 3 by 3 matrix. That means when we put this in matrix form, we will have to put x1 prime, x2 prime, and x3 prime. And then that is equaling to, so where here we only have x3, so this would be 0, and this would be 0, and then our x3, and then this would be 1, 0, then -1. And then our last one, there is no x2, those will all be 0, or no, there's no x3 prime, so that'll be 0, then multiplied by x1, x2, then x3. This one you can easily find the eigenvalue, mostly because we have a column of zeros, so that means our eigenvalue will be lambda is equal to 0, but what we don't know is, well, it's going to have a multiplicity of 3, but we don't know how many blocks there are. So in this case, there is only one block. But yeah, our Q matrix will just be 1, 0, 0, 0, 1, 0, and then 1, 0, 1. And so yeah, now to write our solution, well, it's fairly simple. It's how we usually do it. Because it's multiplicity of 3, one block, that means there's going to be one ordinary, 2 general. So again, this is going to be v1, v2, and then v3, and then v2, v3 all correspond to v1. So our solution will be x, column vector x, which is this part right here, is going to be equal to c1 e to the 0, so it's just 1, so it'll be c1 multiplied by 1, 0, 0, plus c2 multiplied by is going to be v2, so it's going to be 0, 1, 0, plus t times v1, so this would just be plus t, and then plus 0, plus 0, and then c3 multiplied by is going to be v3, so 1, 0, 1, plus t times v2, so it's going to be plus 0, plus t, plus 0, and then plus t squared over 2 factorial times v1, so this would be t squared over 2 factorial plus 0 plus 0. And so that will be our solution for this problem, and then you can just rewrite it or clean it up a bit by getting rid of these zeros. Or another way of writing this is x1 is going to be equaling to c1 plus tc2 plus c3 times 1 plus t squared over 2 factorial. x2 is going to be equal to 0, 0, so c2 plus c3 multiplied by t, so tc3, and then x3 will be equaling to 0, 0, 0, so x3 is just going to be c3. And yeah, that is pretty much it for this video. I went under 15 minutes, so that is good, but it was slightly longer. But hopefully these are like the 3 types of cases generally that you'll be running into when solving these. So hopefully this helped you guys, and I'll see you guys in the next video.